switch. So yeah, it's we've learnt a lot about building serverless systems, and we're hoping to kind of show you some of the things we've been through today and how we've re-architected some, like our whole forum system, we've now re-architected it because of some of the limitations that we did, the way we originally built it. So I hope to show you some like really meaty real-world examples of building serverless systems at scale.
Yeah, and one other thing before we get into our talks. So we run Serverless Conf. We ran it 3 times last year. Our last conference was in London at the end of October. And if you go to videos.serverlessconf.io, you get access to all the videos, all the talks, all the presentations by everybody who was basically at Serverless Conf. Those videos are awesome. Please watch, they are a lot of fun. Really interesting. And our next Serverless Conf will be in Austin, Texas at the very end of April. So I hope to see everybody there. Please, yes.
People convince your managers to say.
Please, I will personally talk to each one of your managers. Yeah. So anyway, without further ado, please welcome Simon.
Thanks, guys. Great intro. Before I start, just a show of hands here out of the group, who does mostly application development, scripting, those sorts of things? Put your hand up if you do that. Okay, and who does mostly kind of infrastructure-y type stuff, marshalling things around? who's too scared to admit what they do? Thanks a lot for that, guys. So my name's Simon Waight. I run the Azure meetup here in Sydney. We are hosting here at TankStream Labs as well. Our next meetup, which is next month, is already full. There's some space left in a meetup we're co-hosting with. Ignite, which is the main Microsoft event in Australia every year, is on in a couple of weeks. We're lucky enough just after that event to have the Logic Apps team in town. So we've got 2 of the guys from the engineering team from Redmond. They're going to be coming along to that event and talking to us. So it looks like it's already fully subscribed, but go and check it out nonetheless. Serverless. I don't know, maybe I should call my meetup meetupless to make my life a lot easier. I guess, so the first rule of serverless meetup or serverless club is what? You don't talk about servers. Sorry, tonight I'm not going to talk about servers. Although the name serverless is interesting. You probably know who this man is, CTO of AWS. This is actually a tweet of his from the middle of last year. And I think it's interesting. Here's the man who's the CTO of probably the #1 cloud vendor who's held on to the serverless term, saying, I'm not really sure that serverless is the right way to call this thing. And then AWS has gone out and embraced it fully and gone, yeah, we're all serverless, which is fine, there's nothing wrong with that. I'm going to talk to you today about microservices using Azure functions. I'm going to use a case study of some stuff I've been doing with a customer for about the last 6 months using functions. So we're kind of early adopters pre-general availability of the functions capability in Azure. We've been lucky because this customer's only building kind of early stage proof of concept systems, so they've kind of said to us, knock yourselves out and use whatever technology in Azure that you would like. Being the kind of guy I am and not wanting to have to feed and maintain infrastructure, the idea of functions and event-based programming really appealed to me. So the idea of looking at functions to solve a problem in my mind was a good one to take, and really what I want to talk tonight to you about, and demo as well, some of what we've done is some of the lessons we've learned using Azure functions. It is a fairly new service in Azure. It sits on top of another PaaS service called Azure Web Jobs, which themselves are an adjunct to what was called Azure Websites, which are now called Web Apps. #1 part of my job in this space is to keep up with all the name changes, particularly in Azure. The last 2 years has been interesting. So what is it that we were building? It's an e-commerce platform where a consumer can choose a basket that they know that they've prepared at a particular physical site and choose to pay for it using a mobile device. Now that might seem a bit abstract. I can't go into too much more detail than that, otherwise I'll give away what the customer does for a business and they'll be happy with me doing that at the moment. It will be going into live site trials in the next month or so. So this is real stuff that's executing real transactions using real money. It has done it in the past during field trials, and it will do it in the future for real customers with real credit cards. So as I said, first release is really just an opportunity to test and learn. So we're not looking to necessarily build the world's most refined gold-plated solution. It's an opportunity to try out the technology and understand where the sharp edges are, and we've certainly found some along the way, so hopefully I'll be able to share some of those with you tonight. We've tried to keep it platform as a service, PaaS, serverless as much as we possibly can. There is a little bit of IaaS thrown into the mix, and I'll take you through a high-level architecture diagram in a second to show you how that fits in. But we've tried to minimise that where we can, where possible. We tried to take the idea of microservices at their purest form, where an individual service will do precisely one thing. So consequently, we have a lot of small moving parts on the back end that are held together with queues. We're lucky because we can run the process mostly asynchronously, so that pattern works really well for us. Most of what we're doing can be managed offline, and the customer will receive a notification on their mobile device once the actual application has gone through and processed their payment, and they get a post-transaction email follow-up with a receipt attached to it as well, as you would expect. One thing that we chose early on to do is, because of the volume of transaction information that's going to be generated both from customers using mobile devices at scale, plus the volume of transactions that will come out of all of the retail sites for this customer, and we take all of them, we will push those into Azure Data Lake, which is effectively just a big bottomless pit where you can put structured or unstructured data for later use in some form of analytics engine like Hadoop or whatever your large data or big data analysis tools of choice are. So we'll take a look at that as well. So the solution demo I've got tonight includes that capability. We front-ended it with event hubs. So you'll see we use a mixture of Azure Event Hubs and Azure Service Bus, and I'll go into a little bit more detail about why we made that choice when we put the application architecture together. Patterns that we used. So if you've built detached microservices systems at scale, you'll know that it becomes a real pain in the backside to try and figure out where stuff failed. The way we manage that in our system is that as soon as a message enters our system at the very edge, it's given a unique correlation ID that then lives with the message through its whole life cycle in the application. Unfortunately, I didn't have enough time to pull out a clean version of the application component that allows us to go and trace those messages through the back end, but we can literally see when a message enters a processor, which is a microservice, the processing that was performed on it, and when it exits a microservice, and we can then tell by that the telemetry, the time it took for it to actually go through that particular part of the process, and potentially where it failed, which is a big part of the reason we want to have that traceability. Happy path is great, who cares, it all went through, maybe the customer's not happy because they paid the wrong price, but that's an end user error, it's not a system processing error potentially. So a POCO is a plain old C# object. What we did for this is we take our POCOs and we serialize them to JSON, and then the messages we pass around contain that serialized JSON, and then on the other end what we do is we deserialize it back into a POCO. I'm a C# guy. I could just as easily have written this in Node.js if I'd wanted to and process the objects that way, but for me and for the people that I work with and people at customers that are going to look after this stuff potentially longer term, C# is a fairly familiar space for them. And the ability to serialize and deserialize that was really quite appealing for us. The additional benefit is that when we add fields upstream, when it's deserialized downstream, anything that gets added to the JSON object is ignored, and we don't end up with weird deserialization issues because object shapes mismatch. So it allows us to stream changes down the chain of microservices without having to worry too much about deserialization issues. Microsoft loves the Newtonsoft JSON space, and that serializer and deserializer is pretty rock solid, so it deals with most of the edge cases, although we ran into some interesting challenges with date time, which is probably a universal problem, right? Date time just undoes everything. So in order to make these items trackable, what we did is we inherited an interface, we implemented an interface which required that our messages that are passed around have at least 3 properties attached to them, which is a customer ID, correlation ID, and I think a location ID. And what that allows us to do is it allows us to drill into and find messages and guarantee that those fields will be populated at all times. So it meant being forced into some certain design decisions where maybe we could have thrown away some information to make a message smaller on the wire, but from a traceability perspective, it meant that we could guarantee that when this message got logged by the system, it was going to show up with the data that we needed, which then allowed us to build a reporting engine over the top of it to go and find out later what had happened. Our reporting engine is really basic. Basically drill through a series of drill-ins, and then when you get to the very bottom of the stack, we just literally pull back the raw JSON object that got logged and display it to you using a prettified view of the JSON object, so you can literally see the raw message that was produced by the system at that point. We could go away and build extra layers on top of that, but for the purpose of what we were doing, we thought that worked quite well. What else? So I talked about this. Each function, self-contained, it does precisely one thing. So we have a function to match a customer against a pending payment, to then find the customer's profile in Active Directory B2C, to then, we won't see it tonight, but to calculate any discounts they've got on their basket and apply that to the value of the basket, to then go and pay. We've got a function that just does payment, that's the only thing it does. And then finally a function that will send a notification to a customer using email. We have some other associated functions that don't fit into that stream and do offline processing. They're a little bit more basic than this process, but again, they still only kind of do one thing: pull details out of a loyalty database, do some batch processing, generate a file that we put into log storage. As I said, we put all the messages as JSON serialized POCOs. Early on we thought, oh, we'll just use the standard service bus serialization, let it serialize and deserialize to and from XML. Problem with that is that functions the way we're using them, we declare the classes actually in the function rather than have a centralized repository of places where we can pull those objects from. What happens, the way functions are compiled at runtime, is they end up with their own namespace because of the way they're compiled, which means the namespace of the XML objects at serialization and deserialization don't match, and you end up with a deserialization issue downstream. So pretty early on we made the decision, serialize it to string, put the string into the service bus message, and then send it on to the next function, which does the reverse. In terms of performance of that, I don't know, it doesn't really matter to us at the time being. That'll be part of our at-scale test and learn. We'll see what impact we have on that, see if that makes sense. Traditionally in .NET, XML serialization was a pretty costly exercise to go through, so you generally tended to avoid it where you possibly could. JSON doesn't seem to suffer from that, although I'm sure at scale we might see some issues at the edge. What else? So I don't know how many of you are familiar with Azure Service Bus. So when you put a message onto Service Bus, a consumer that's listening to that can do two things with it. It can be triggered to receive that message, process it, and the message is then effectively marked as processed on the queue and is not available ever again. The way functions work by default is they use a thing called peak lock. What they do is if the function executes and it has an exception at any point that's unhandled, it will leave the message on the queue. It won't mark it as processed. We decided not to use that behaviour because despite the fact you have dead letters where it'll try out a certain number of times and then die, we had no control over that. It was literally baked into the service bus, so we decided that we would be exception safe in all of our functions, and then we built our own retry mechanism to allow us to actually track the number of times messages got put back onto a queue for a processor to try and reprocess them. Some of the processes like payment, we don't try and reprocess payments. If for whatever reason we've actually processed the payment and then we get something that causes an exception in the function to die, we don't want to reprocess that payment, so we'll put the fact that it errored off to one side and we'll go and investigate it afterwards. I'd rather do that than charge a customer several $100s multiple times because our retry logic says try 4 times and then give up. We charge them $1,200. I'd rather that we deal with that issue than a customer have to deal with a $1,200 overpayment. That's it. Yep.
Is your monitoring architecture for all these sort of tuples that you were talking about with unique correlation ID, is that done through the message bus, or are you?
No, so we actually add a property to the POCO that goes around inside the message bus, and we manage that ourselves. So
are you logging events? You talk about when it arrives.
So we are choosing when we do that. So in our functions, we will say at this point we care about the life cycle of this object, and we will go off and we will call a mechanism to allow us to log it. I don't have the code here. I can walk you through that if you'd like to see it, but I know where you're coming from. You're kind of thinking about like an aspect-orientated programming model where it passes through a gate in your code and you've got some listener that effectively goes, oh, I care about that, push it over here. There is probably a way we could have implemented that. We were working on a fairly tight time constraint.
So what do? You just dump everything to a common store?
Pretty much, yeah. So we're using, we'll take you through the architecture diagram and then we'll have a look at it running. It's probably going to be the easiest way. And then finally what we did, and this is a pattern that I see sometimes not adhered to, is we've set up discrete send and receive policies on Service Bus. So by default, Service Bus gives you a default access key that allows you to do manage, listen and send on the Service Bus. That's a really bad idea to use that, because if you do something wrong in your code and you delete the Service Bus, then all hell happens. So we allowed ourselves to have send and receive. It's not a big overhead to do that. SAS tokens do expire eventually, so we will have an overhead down the track to go through and refresh those connection strings in our configuration, but we thought that was a much cleaner pattern, and then we know when we're actually calling a particular in a particular function, we know when we use a particular connection string that we're actually either going to send a message or receive a message.
So, quick question.
Yes.
When you say logging, where are you logging to? Like what service?
So we use DocumentDB. Yeah. So because we're sending and receiving JSON messages, and the API we're using from our mobile client and from the source of our basket information is sending and receiving JSON. We're literally just dealing with JSON everywhere, and we just store it as documents in DocumentDB, which actually pose some interesting challenges around design, because coming from, as I do, from a traditional relational database model world, think, oh well, this would be really easy if I just had a table with that and a table with that and a table with that. And you just need to kind of, take a ruler out and smack yourself over the knuckles a few times and go, I need to stop thinking about this as relational data and think of it as a document, which it kind of is. I think it's the last slide and then I'm done. Yep. So things we did use, or things that we probably should have done in this. So when we started our journey on this path, there wasn't any local development tools available for functions. There is a local CLI and some development tools available in Visual Studio now. They're still very early release, but not fully baked. And it's probably one of the weaker points of functions. Microsoft generally tends to be pretty good about local tooling for most of their services. Not these guys, because as you might expect, they're built on top of web jobs. So you've got to have some local environment that allows you to replicate that. We didn't do CI/CD for this. Again, that didn't really exist. So all of our functions live in a project in Visual Studio Team Services. There is CI/CD capabilities now that they've delivered. And there are some people in the community that have come up with some novel ways of deploying these things. They do some interesting under-the-cover stuff with the way that functions run, so it's not like a traditional web app, web job where you could actually deploy them. So a lot of people tried to force them into that model that didn't really work early on. And the team's working hard to improve those two things. They just released the ability to deploy compiled assemblies. And you might go, well, that sounds, like an anti-pattern, because you create one big monolithic assembly and put it over there, and then all your functions refer to it, and goodness me, you've got a monolith instead of a set of microservices. What it does allow you to do is the common code that you use between your microservices/functions, you can compile it into an assembly and you can deploy it into each of your functions. So you'll see the way we're doing it with the CSX runtime files. There's some clear benefits to being able to take some of those elements and put them into a single compiled element that you then deploy into a runtime. There's some PowerShell stuff coming. I think F# is there, Node.js is there. I have seen talk potentially of Java also being there. Not sure why you'd ever write Java in there, but that's okay. If people are still into those sorts of things, I guess we can't stop them. And then the last thing that we probably do is maybe look at, instead of just using queues, maybe look to using topics instead. And then that allows us to do other message processing upstream, so we can create a more true pub/sub type model where a function can put a message on a queue and have a set of topic subscribers receive that. At the moment, we're very much message goes in here, message comes out here. And that was part of the reason we chose event hubs at the front. We can replay event hubs over and over and over again if we want. Messages don't disappear off of that until they've been expired by the underlying infrastructure. I will show you how we're processing those messages at the moment, but we could have used event hubs here, but it's probably overkill for what we were going to do with this system. So that's it for me talking. Let me just quickly show a diagram of what we did. How are we doing for time? 18 minutes, all right. Anyone got any questions while I bring up the diagram? Wow, pizza's here. Everyone's going, oh, I'm hungry. Stop the functions. Well, I think Peter's also got, so I'm wearing a functions t-shirt from the team. I think Peter's got one of these as well to give away later. So keep your ears out for a question or something. I don't know, we haven't figured out how we'll figure that out just yet. But all right, let me get up the diagram.
Simon, what was your test strategy for the functions? What did you guys end up doing?
Test function. Good question. Maybe I should go back. Hang on a second. Sure. So,
Test is out.
yeah.
Surely you didn't write a line of code until you'd written the test.
Oh, let me tell you a story.
Real developer.
Let me tell you a story. So, I should have brought a picture along me dressed as a cowboy. So yeah, it is a weak point. Again, it's not one of those things that you don't really get a lot of because you don't have local tooling baked into this system. The way we've built these things using CSX files, you effectively write the file, you save it, it's compiled by the runtime, and then because we're using event-based listeners on a queue, you push a message into the queue, it triggers your function and it runs. So yes, we probably could have stubbed that. The reality is that the system we were building was greenfields. We didn't have any external dependencies on what we were building, so we could literally run this up as a development environment and test as we went. So we were using Service Bus Explorer to push messages in. In fact, the way I'm going to run a demo tonight is to use some slightly modified test harnesses that we had to allow people to generate test data to push into the front end of our pipeline, and literally the way we tested is we pushed messages all the way through. Where the data gets generated from a basket perspective, we can generate those messages at volume, and then we had literally people using the mobile solution that we built to then go and make sure the payments are working. So, look, is that the way we should be doing things? Absolutely not. We had the flexibility to do that because of the context that we were doing this project in. Again, the fact we don't really have that test harness capability in the functions framework kind of limits our ability to do this. It's probably one reason looking at the compiled functions would be better, because you could potentially write unit tests against some of those compiled functions that you then compile into a function to deploy. We didn't see that as a necessary part of what we were doing, but yeah, so that was, does that answer the question?
Yes.
Yeah.
Can I just drill down just a little bit? With Lambda, and I'm a little bit biased, but with Lambda, it's just an entry point.
Yep.
So why couldn't you write code, why couldn't you write a test harness that called that entry point regardless of the rest of the event bus and everything, and just hand it a payload and do business logic or unit testing on that single...
Oh, we could have done.
It sounds a little bit like you had to run the entire platform every time you wanted to run a test. So is that not inefficient?
Not particularly, no. No. So, look, yeah, you are
Did
right.
it slow down your iteration though? Like you write one line of code and then you wait for it to compile, deploy, and pump it through the system?
No, it was, so look, it didn't impact us. Because of the way the system was being built, it wasn't a big challenge for us. We could have gone down that route. The customer is interested in innovation at speed, and they're prepared to trade off in this context against what that means from an overall approach to delivery. They would rather see innovation more rapidly and less stable
Until they have operations.
Yeah, so...
And then they're too afraid to make a change.
No, so this will run at precisely one customer site initially. That will be a trial site. It will be using real customers, but it will be done in a way that the customers know that effectively it's a beta system. So is that the right way to do things? Absolutely not. And if I was sitting in that seat, I'd probably be going, oh, these guys are who doesn't know what the hell he's doing. But the reality is we had the ability to make that trade-off. The customer was focused on speed to market without necessarily having to have a gold-plated unit test out the wazoo, green ticks. All the other components that are not based on functions that use some form of compiled deployable have CI/CD pipelines attached to them in VSTS, so Visual Studio Team Services. They use Release Manager to do CD, and those builds have unit tests attached to them. So where we could use that, we did. It wasn't a massive overhead to us to do it in those circumstances because the infrastructure allowed us to do it rapidly. But for functions, it's not quite that straightforward. We didn't have a huge team, and for the purpose of this test and learn exercise, that wasn't deemed as a necessary part of what we had to do. I'm the architect for that, so I'm the person that made that call, so if that sounds wrong, I'm the man to talk to about it.
It's a pragmatic decision that's been driven by the circumstance at that
So
time, and there have been lots of
we are,
projects that...
yeah, absolutely. We are absolutely focused on delivering business value to our customer as quickly as possible. That doesn't mean we throw our engineering rigour with it, but it means that we're pragmatic. Where can we do things that allow us to fix things quickly to make sure that we're delivering stable software often? So absolutely. And did it cause us issues? Yeah, in functions it caused us issues, for sure. But when you're testing and downstream you're missing a property, trace it back through, you use your telemetry, you go, oh, I didn't add it here, you add it here, and then it shows up downstream. And then we can go back on an event hub for a period of time. We can go, okay, roll the event hub back 2 hours and replay all the transactions through it for us, and then it will push them back through the system for us if we want to. So yeah, not ideal. I'm the man to complain to about it though. The customer hasn't complained so far. Where to start with this? How much do you want me to talk to about this? Would you prefer to see a demo?
Demo.
Or would you prefer to see pizza?
Demo.
Alright, quick demo. Okay, alright. Someone set some context. Right. So let's just take a quick look at what we've got sitting behind this. So we have Data Lake Store, which is our bottomless pit to put everything in. We've got a NoSQL document DB, which is where some of our transactional information lives in the system. Here what we did is we temporarily store basket information for payment in a document DB to allow our mobile application to retrieve that information displayed to the user. We use the time to live capability of document DB to say after an hour just chuck away those documents and we don't care about them, and we know that they're in Data Lake, so we're cool with that. And after an hour, if a customer hasn't paid for a basket, they're probably not going to pay for it. They've probably paid for it some other way, so that's fine. We use SendGrid to deliver our receipt information to the customer. The demo tonight doesn't use the full system, but we have a fully templated SendGrid set up, so we can send properties across and tell it what template to use, and it will just do template replacement for us. App service, which is probably our main focus. It's on the bottom. Just scroll down. In this instance, I'm using a consumption-based plan, which basically is a new type of plan Microsoft's announced, where it's consumption-based rather than setting a specific threshold each month that you will say, I want to spend $70 a month and it will guarantee me this many gigabytes of memory, this much disk space, etc. Consumption-based is basically use as much as you like and charge me in gigabits per second or gigabytes per second, and then you set a threshold up to which you are happy to go on that plan, and basically you'll be throttled at that point. We haven't used that in Anger yet because it didn't exist when we started our project, but it would be something that we'd probably consider in future, because then we'll get that scale in, scale out capabilities without having to worry too much about what service plan we're running our functions on. Then we have 2 event hubs sitting in Event Hub namespace and a series of service buses in Service Bus. I have a couple of web apps that we use to generate test data. Let's see, let's go and pull up one of these. So for the purpose of this demo, I put all the function apps into a single app plan. In production, you would split them out into multiple app plans so that each function can shrink and grow as it likes. There will be a lot of commented out